Okay, it is 2 o'clock. So welcome to Jina's Engineering All Hands. I am 𝗙𝘀𝘁 the DevRel lead here at Jina in sunny Berlin. Hang on. Yeah, that's better. So, yeah, first of all, we're at the Jina Engineering All Hands. So the big question is, what is Jina? So Jina is, well, you can read it here. It's an open source cloud-native search framework for any kind of data, powered by deep learning. When we say search framework, that means you can use it to build your own search engine. For if you're building the next Amazon.com, you need a search engine. If you want to search for academic papers, you need a search engine. If you want to build the next TikTok, you'll need a search engine. We're here to provide that kind of functionality. When we say any kind of data, we mean any kind of data. Most people think of search as just typing text into a search box, but we go beyond that. You can search by uploading an image and it'll find similar images. Or you could upload an image and it'll find video clips that are similar. Or you can upload a video clip, you can upload audio. Heck, you can even upload protein information and find similar proteins. So if there's a model, a deep learning powered model to do it, it can be integrated into Jina, and then you can use that as a search input and output. Our All Hands is every month we have a public event online. We summarize what's going on, we share our engineering goals and do some show and tell, give tips, and then we open it up. Anybody in the community can ask us anything, and we're always super open. It's on the second Tuesday of every month, 2 p.m. to 3:30 p.m., right here on Zoom. A few quick updates before we begin. On July the 27th, we've got a Jina workshop at 𝗷𝘀𝘁 2021. July 29th, here in Berlin, we've got our second Jina and Tonic event. So we'll be meeting up around the middle of Berlin, and all of our community are welcome to join us for a beer, a gin, a glass of milk, or whatever drink you so desire. And at some point, we're also planning a workshop in South Korea with AI Network. We're still working on a date for that, but we'll keep you all posted via our Slack group. So today, our engineer Christian is going to be speaking about Jina Hub 2.0, and I guess this would be the best time to hand it over to him. So I will do that now, and he can share his screen.
Yep. Oh, I cannot share my screen.
Hang on.
Should work now.
Oh, okay.
Yes. Can everybody hear me and see my screen?
Loud and clear.
Yes.
Okay, cool. By the way, engineer Christian sounded so official. I like that. Yeah, so this is the agenda for today's Engineering All Hands with Jina. We're going to cover a lot of the changes around the executors, but also how you would use executors. And just look at the agenda. We'll cover the executors, the hub. We'll have a demo about how to use the executor in the hub. Then we will delve into a specific type of executor, the indexer, and how you use it when you store your data versus how you use it when you search data. Let's delve right in. Right, so just a short recap. This has probably been covered in other announcements, in other guides, in other documents that you might have read about Jina. But the main changes for the Executor 2.0 API is that there's no more driver as there was in 1.x, which made things quite cumbersome and difficult to understand. There was quite a steep learning curve. Now, all the logic that you would need to handle a specific request is all in your executor. So it's much more contained and easy to reason about as a developer. And each executor can have arbitrary endpoints, which are the methods that that class has. An executor is just a class, a Python class. And each of these endpoints will receive 3 pieces of information from the flow. It will receive the documents, which will be a document array. This is your data. It will receive the parameters. These are the parameters to a specific request, not to the entire flow creation, or not the arguments to the initialization of the executor, just so we're not confused. And then in some cases, you will receive a docs matrix, a document matrix, which will be a list of document array. So for example, you might receive this if you use shards and then you want to merge your results from the shards. We will not delve into this. It's covered in the documentation. We'll link those at the end. But just so we're clear about how the endpoint will look like. Then the Jina Hub. What is this? Oh my God, this is amazing. So this is basically a cloud catalog of executors that you can use for Jina 2.0. And they are based on Docker images, so you don't need to install anything. We'll see how easy it is to use them. They are distributed via a cloud distribution network, a content distribution network, so they should be available across all zones. And executors can be public or private, and which is up to you, the creator. You can either have them be public and then they'll be discoverable and usable by anyone, or they can be private. And in that case, you will need to share a specific key with whoever you want to have access to it. For example, in all your company or organization. And they're very much plug and play. They can be just dropped into your flow. They respect the same API as all other executors. So you can just add them at any point in your flow. Of course, you need to know what it does and how it would affect executors downstream, but it is very much just copy and paste, and it works. The basic usage is this, and we will see this in the demo. You need to push your executor to the hub, which is this command. The dot represents the current directory. We'll see how the directory looks like. And then when you use it, you will be given a specific uniform resource identifier, a URI, this piece of string here, and you can copy that and add it to your flow.add method. At the moment, we are also working on a pretty web interface for searching and filtering for executors. So watch out for that. It's in the works. Any questions so far before we jump into the demo? Okay, nothing. So I guess we'll just jump into the demo, and I guess more questions will arise afterwards. So just an outline of the demo. We will be writing a simple executor with an endpoint. We will push this to the hub. We will then use this in a flow, and we will see how we can pass arguments to this executor. So let's just jump into PyCharm. Let me know if the font is too small. I try to zoom in, but might be too small.
It's okay, looks good.
Okay, cool. So this is our directory here, this one. We have requirements, we have our flow, and we have a folder with an executor, this one. So our executor doesn't do anything super interesting. It basically takes the documents and it logs them. And I'll just go now through what the different pieces are and how you put them together. So like I said, we have a folder, and this is required for the hub to be able to identify your code and package it. So you need to have a folder with an init so that it's a Python module. And if you want, you can have your class in here, but I chose to put it in a separate file, which also works. Then you need to inherit from executor, which does a lot of the magic behind the screens. And then you need to make sure that you initialize the parent class with the star args and the keyword arguments. Then otherwise, this is just a normal class. It will have arguments. You will have some logic in here in the initializer. Nothing really worth mentioning here. Now, the magical part comes here. You will have a decorator on a method. This decorator tells Jina, the flow, where to send a specific request depending on the endpoint that you specify in that request. In this case, we are saying send this to all the endpoints, but every endpoint will just default to this. But you can make it more restrictive by saying requests and then on, and then let's say we want this to be called only on index operations. And this string can be anything. It can be update, but it could also be whatever method you want to call it. I will keep it generic. Then, like I said, the arguments to the endpoint will be docs, which is document array. This contains the data, parameters, which contains whatever parameters you're passing to the endpoint. And then there are the doc matrix, which in this case where I'm not using, so I just hide them away onto keyword arguments. In order to access the parameters, you just need to use the Python way of accessing dictionaries. You can use get, or you can use square brackets access like this. In this case, I choose to use .get, and I am looking for a specific parameter. And if I don't get it, I default to an argument that I created in the init method, this one. So like I said, this executor doesn't do anything fancy. It just logs the first X documents in a request. So it logs the request time, and then for the number of documents, I say I am searching with document ID, I log the document ID, and then the content, so nothing fancy. Now, the magic of Hub is that you can then go to this directory, let me just quickly, and then, so here we just have init.py and request logger, ignore the py cache. In order to push it, you just do Jina hub push, and then we want to make it public, and we want to use this directory. If you're uncertain about any of the command line arguments, you can also do help, and you can see here all the arguments. Yeah, so the path is the one that is required, and then you can do specific things with overriding a specific other existing executor if you have that executor's secret, and then you can make it public or private. I will make mine public. So let's just say Jina hub push -- public, and then current directory. And then here you'll see the build process from here. It gives you all the arguments that you've used, and then this is something very important. The secret you need to remember. You need to keep this token in a safe place, because if you lose it, there is no way to retrieve it. In my case, this is a public executor, so you don't need to specify the secret when you use it here. It just gives me this ID. That is the unique identifier of this executor. You can also have custom aliases, but I'm not going to get into that here. So now I will just copy this string into my flow here. I've already done this, but just so you see, it is the same one. It's the same one. Now, let me take you through what this small app is doing. So I'm creating some documents. I'm assigning some content to them, nothing special. Then when I create the flow, I use this image here. Instead, I could have used request, I can't type, request logger as the class directly and import it. But let's say that I don't have access to the code, and then I use this. And this will start up a Docker container with the image that we just built and deployed. And Jina will connect to it and run, pass the data to that executor inside the Docker container. Now we have different arguments that you can use to pass to your executor. In order to pass arguments to your class, you need to say override underscore with and then provide a dictionary. This dictionary corresponds to your arguments. So my case is just this one. And otherwise, it will just not overwrite the default. But in this case, the default is 1, which is also 1 here. We could change this to say 3. Then, if we want to have the workspace be saved to our local disk instead of the Docker container, we need to specify a volume, like as you do in Docker. The workspace in my executor is used. If you look here, we open a file in our workspace called log, where we store all this data, where we store the requests. So I would like to see that without having to go into the Docker container and see the files there. So I use this volumes argument. It's the same syntax. We map the folder called workspace, which does not exist currently, but it will be created, to a folder called internal workspace in Docker. Then you can also override the arguments of the executor class. So the executor class takes care of some meta arguments. In this case, we only care about the workspace. By default, it would have just stored your data in the name of the class. So we would have created a folder called request logger and saved your data there. But we want to make sure that the workspace is the same as the one we mount. Here you can also pass name, which can change the name of your executor so that it shows up with a specific name when you log, but we don't care about that. And then I'm just indexing the documents, passing the endpoint here. Remember, our request logger does not care, so it will do the same operation no matter what endpoint you pass here, but this is important when you want to do to have a specific pipeline for index versus search and so on. And inputs, which are the documents we created here. Now, let's also look at parameters. Remember that the endpoint takes a parameters dictionary. And here I expect log docs to be some number, which can be an int. And I'm giving the number 2 here. By default, it would have just used self-default log docs, which I initialized by default to 1, but then I override to 3. So let's just see how this would look like. We can see the, let me run it from the command line. So we just run Python flow, and we will see here that this is pulling the data of the image, and then it's running it, and it should be done. Here we see a bunch of logging. This is mostly logging the parameters that you've sent, but we also log something from our request logger. We have here request being processed, and we can see that here. So now we can see that it's also created a workspace with the class name. 0 represents the shard number. We won't get into that, but just so you know. And then here we will see the logging, and we can see the effect the parameters have. By default, we have 3. And in the first request, we don't pass any parameters to override that. So it will log the first 3 documents. And we can see here, let me zoom in. We can see here request at the time, blah, 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 with 3 documents, and we print all of them. But then in the second request, we only want to print the first 2 documents. And this is what happens. That's basically it for the demo. It's just how you use it in, how you would push an executor, how you use it in the flow, and how you can override arguments, how you can attach a workspace, and so on. This code will be available in a repository. We will link that at the end. But before I continue with the indexers, are there any questions? Okay, no questions unless somebody's muted and trying to talk. Then let's proceed. This is a bit more advanced, but don't get too intimidated. A specific type of executor is the indexer. The indexer takes care of storing your data, but also searching your data. And let's first go to the top level view. What do we care about when we store/index versus when we query or search? Well, when we store, we want to make sure that we have that we can access these types of operations. We can index, we can write, we can update, we can delete, and we can read. So we have the CRUD operations. And this will be your source of truth for your data. We use Postgres and LMDB as two storage engines, and they are very resilient and very high performant, but they are meant for these sorts of operations. While on the other side, the search flow is meant to be used to perform vector similarity search. And in that case, we are using 𝗙𝘁, we are using 𝗁𝘁, we are using NumPy. We are currently working on HNSW. So it's a bit different. So we realized this and we started thinking about it in two different ways and not having them be part of the same flow. So when you store, you perform these operations and you use a storage indexer. And when you want to communicate that there is new data in the storage, you perform a dump operation, which will create a snapshot of your data, which will then be loaded by the search flow. And the search flow is the one that performs the vector similarity lookup and then retrieves the metadata of the vectors that are the matches for your queries. And you can update the search flow via this rolling update operation. Again, this is documented and we will send the links out. But just so we're clear, what indexers do, they store and retrieve documents. And there are two types: storage, which store and retrieve the entire document, embedding metadata, tags, whatever you want by ID. And then we have searchers, which specialize in searching. And the main types here are the vector type. We have 𝗙𝘁, we have 𝗁𝘁, and we also have NumPy. It's not listed here. And then we have compound searchers, which combine a vector searcher with the lookup for the metadata. We are also working on a simple indexer, which combines both, and under the hood uses a document array, which we saw earlier. And this is for simple applications where you don't care about performance, or for some reason, you don't want to go expand in this way, and you just want to try things out. But it's still very efficient because it uses MEMMAP and it optimizes RAM usage. And that's it for indexers. Any questions here?
What's the ETA on the simple indexer?
Hard to say. We are working on perfecting it for examples. So we are updating all our examples to 2.0, and most of them will be using simple indexer. So we're trying to make sure that it covers all those cases well. And once all the examples are done, which I think we're almost there, that one will be merged as well. You can already have a look at it. It's an open pull request on the indexers repository, and you can use it, but we don't guarantee that it's gonna work very well yet.
Nice.
Okay, if there's nothing else, I will try to copy these links in the chat so that everybody can have access to these after my presentation is over. But just so you know, all this information you can obtain from our cookbooks, which gather all the relevant information to get you started with Jina, and they are split by the main abstractions. So we have a cookbook for the flow, we have a cookbook for the document or for Executor, and so on, even for the Hubble, which is our Jina Hub internal name. And I definitely recommend you check those out. The Executor indexers are here. And if you want to see all our executors, like I said, we are working on having a nice web page to search for them. You can go to Jina, to the organization, and then you can filter by executor // and you will see all of them here. Yep, that's everything for me. Is there any other final questions? Okay, then. Alex, back to you, I guess.
All right. Thanks, Christian, for that enlightening presentation. I'll share my screen again very quickly and let you know how you can find out more about Jina, where you can find us. So yeah, we are all over the place. We're now on meetup.com as well as all of these. So if you want to check out our GitHub repo, see the source code, play with it for yourself, get.jina.ai. I'm hoping all of you are currently on our Slack, and if you're not, we would love to see you there. Businessy stuff on LinkedIn, general updates on Twitter, and you can find the recordings of all of our prior Engineering All Hands on Jina AI YouTube channel, along with a whole bunch of other videos. And by the end of tomorrow, roughly, we should have this video up on there as well. Okay, and it's not, whoops. Okay, yeah. So that's the end of the presentation for now, but we've got so many people here. I'd love for any new people to say hi and introduce themselves. Whether you're new working at Jina or new to our community, now's a chance to say hello. Right.
Hello, everybody.
Hey.
Can you hear me? Hi, Alex.
Yeah, we hear you.
Hey there. Who am I speaking to?
Okay, so I will take the occasion. Giancarlo.
Ah, yes. Hey.
Yeah, so we met already, so I will take the occasion of a brief introduction. So nice to meet you, Christian. So present here, we are now working on some open source projects. So we started playing with Jina in the last month, and we are working on some neural search on these, like on the protein structures. So some pretty cool scientific project, I would say. So it's like, as I said, it's just 1 month that we started playing with it, but I mean, Jina itself, it looks very mature. It's very easy to use. And it's, I mean, really, we were able to, I don't know, like already play with some fancy data structures like amino acid sequences, which is not a data type that you usually see around. And yeah, so we are working on that. We met already Alex and Pei, and I mean, we are just a part of the community now. So hello to everybody.
Good to have you here, man. And yeah, you are the protein example I brought up earlier, the first one I know of. So I'm really looking forward to seeing that. Cool. That's all. Do you want to say hello?
Yeah, sure. Hi, I'm from AI Network, which Alex introduced in the beginning of the presentation. We're gonna have workshop together during the July. We're looking forward to having collaboration. And some of our engineers are participating currently right now. So maybe they want to say hello.
I see a lot of Korean.
Oh, one question I received from one of our engineers. They're asking if they can have the PowerPoint slides after the presentation so they can go through to learn more about your demo.
Yep, sure, no problem at all.
Thank you.
I also posted the link to the workshop code in the chat if you want to look at that directly.
Great. And do some of the Korean engineers want to say annyeong or hello?
Yeah. 𝗷𝘀𝘁 or 𝗁𝗁, 𝗁𝗁, they're our engineers. Do you guys say hello? Do you guys want to say hello to engineering team?
Hi there.
Hey, Mitsu. Good to see you, bud.
Good to see you.
Cool. And who else do we have here? Is Swati here? I think I saw her earlier. She's dropped out. Oh, well. Who else have we got that's new? Anna, do you want to say hello? I feel like a teacher telling everyone to be social on the first day of school. Okay, Boris?
Hey. Hi, yeah, I'm just recently finished my master's and I came across the Jina project, so just having a look around, trying to understand it all.
Nice. What was your master's in?
It was more NLP focused, working with transformers.
Oh, very cool. Very relevant. So what kind, any NLP use case in particular?
No, I'm kind of still just trying to be thinking about what is possible. The idea of a neural search system is pretty new to me, so just reading a lot, yeah.
Good stuff.
So I will jump in again because actually, so we talked about this protein project, and actually, basically for these protein structures like similarity searches, we do use NLP models. So, which I think is, maybe it's not surprising if you think as NLP like models for sequences, right? Sequences of words, and so you can pretty easily, maybe not, but I mean, it's pretty natural to adapt these kind of models to sequences of amino acids. So with some good results. So I mean, NLP is definitely, and transformers nowadays is definitely one of the most relevant kind of models in the field, I guess.
Yeah, I guess that's why the project definitely caught my eye. And I was doing distillation of transformers. So there you also work with making a student model have a similar vector similarity to the teacher embedding. So there's a lot of similar concepts.
Nice. And who else do we have here? Honest AI. I thought that was Honest Owl. Sounds a bit like a used car salesman. But great to have you here. I think you're on mute.
Yeah, I am. Sorry, it's a bit noisy here. That's why I'm not talking. But yeah, thanks for the event. Just joined. I missed the introduction. So
nice. Are you working on any deep learning stuff at the moment?
Yes, within my company we have we do provide the AI solutions, and search is at the core. We haven't deployed Jina yet, but I'm following closely what happens in the community. And yeah, I just wanted to say hi and see what you guys have been up to. Mainly when we're interested in Q&A services, knowledge graphs, and neural search in general.
Oh, very cool. Yeah, we've got a basic Q&A chatbot demo as part of the Jina Hello. More info on that is in our README. And yeah, I think we are working on stuff around graph search. I don't know if one of our engineers wants to chime in on that.
Yeah, well, so we are trying to bring graphs into the framework, and we have a small setting where we can do graph-to-graph search, and we are looking in a way to do more advanced examples. And once we have mature, we will release it more officially.
What is a graph-to-graph search?
So, for instance, you can treat, in our example, a molecule. You can embed a molecule given the structure and the link composition. You can extract an embedding and search the molecule with an embedding. That is something that you can do, for instance. Or you can embed graphs with the new graph neural networks into.
Got it. The user input is graph, and the output is also a graph.
For instance. But there is also where you want to embed nodes with more information about the linkage to the other nodes in the graph. So
Yeah, very curious to see that in action.
All right, who else have we got?
Hi.
Alex, oh, sorry.
Oh, sorry, I jumped in.
Oh, hey, George.
Hiya. Yeah, nice to meet you all. I'm working with Jan on the protein search project. So yeah, the idea is that like we're working with Major League hacking and like an open source kind of program. And yeah, we're just kind of having fun, like playing with Jina, trying with new data types. And then if we come across like some kind of issue with Jina that, you know, could be done easier, then we're either to sort of report that to the team or even try and like make our own PR. So yeah, nice to meet you all.
Very cool. Someone else was trying to chime in at the same time, so now's your turn.
Alex, sorry, I mean, we had a quick question on how do you guys use embedding vector to do image search?
Okay, does one of our engineers want to jump in on that?
Yes. So if you look at, for example, NumPy, the NumPy searcher, we take the embeddings that are produced by the models, we store them, right? And then when we search, we perform some sort of similarity comparison between them, like cosine similarity. And based on which vectors get the highest scores, then we retrieve the document with its original data, whatever it was, image, text, probably you said image, it will be image binary data. And then when you get the response back, you would get the score, meaning the similarity, but also the content of the document that matched, that has the highest matches. Yeah, that's basically it. Does that answer your question? Yep. They were so impressed, they were
Speechless.
silent. Yeah.
We took their breath away.
I saw that like in our chat, Stuti asked about how can she get started with Jina in the chat.
Okay. Do you want to mute?
Yeah. Okay, got very echoey for a second there. So the best way is to start with our README. That is the one-stop shop with all the information. So to get a feel for what Jina is and what it can actually do in the real world, we have 3 examples for Jina Hello. We have a fashion search, which is image to image. We have a Q&A chatbot, which is NLP. And we have, I think, a multi-modal search. So with that, you can search by text and image. So multi being more than one, modal being modalities, so ways of searching or types of media. As well as that, from our README, there are links to the different cookbooks. So the cookbooks introduce the 3 main elements of Jina: the documents, which are the input data, the input and the output data, the flows, which is, these are the bits of Jina that do the big jobs, like searching is one example of a flow, or indexing is another example of a flow. First you build the index, then you search the index. And then within each flow you have executors. So these are the bits of the flow that do the individual jobs. For example, if you want to search Romeo and Juliet, one of the executors may chop it up into paragraphs, which would be the unit you search. And then another would encode them into vectors, so you can compare similarity more effectively. And then another executor would build an index. On our blog as well, there is a tutorial for the My First Jina app. And I myself have put up some examples of a Jina app store and a Jina meme search. The meme search is text to text and returns rich metadata like app score, app icon, so lots of stuff, as well as description. The meme search returns images. It's text to image right now, but we're working on image to image as well. Those examples are deliberately kept very simple, so they're easy for other people to adapt. And then, of course, join our Slack group, because that's the best place to get support. And if anyone else has anything to chime in on this, now's the time.
Yeah, I guess like, so I've been learning Jina in the past like 3 weeks or so. And there are a lot of resources. I'd say like currently the resources exist more on the advanced end. It would be super cool to see a hello world example that takes you through step by step and kind of assumes nothing. I don't know, this may be easier like if you know how a beginner thinks, and if anyone wanted to work on that, I'd be happy to be the idiot in the situation and give some feedback on that.
Okay,
So you could,
yeah, that sounds exactly like our tutorial. Susanna?
yeah, I was just going to say that. So I think for the first step, you could use the tutorial. So that assumes that you don't know anything or you have no previous knowledge with Jina. So maybe that could be useful for you.
Yeah, I've worked through that. But I believe if it's the one I looked at, it kind of just says, we're going to gloss over executors for now and import them.
Yeah.
But like, I think writing executors could be included and would be helpful. Just
Yeah,
like
so
using a simple model to do the encodings, for example.
definitely. So we only have that one. So definitely it's the one that you're talking about. So the first tutorial doesn't go into executors. That is supposed to be the second part of the series that is coming.
Okay, awesome.
And with Jina Hub just around the corner, in many cases, you won't even need to write your own executors at all. You would just call them via Jina Hub
Yep.
slash, transformer torch encoder or whatever. So
yeah, so you could use the ones that we have. I think the presentation from Christian was really good to see how you can just use one that is already existing. But I totally agree that we need another tutorial to show how you could make your own if you want to. So thanks for letting us know.
No worries.
always happy to hear feedback.
Especially if it's good feedback.
Oh yes, feedback and compliments about my appearance and you name it.
You're muted.
Anna, are you there now? She's very quiet. Ron, do you want to say hello?
Yeah, hello. I'm not sure if I'm the Ron that you're referring to, but I'm one of the Rons here. Yeah, at work we're a very heavy user, or our main product is makes heavy use of Solr. We probably have almost 1 billion document Solr cluster. Are very interested in new and upcoming search technologies, and are extremely interested in your product and project and community. So mostly just getting started. I noticed you guys on Reddit, I guess, when 2.0 got released. And I'm just mostly here just to learn more.
Fantastic.
Which subreddit did you find us on? Can you remember?
I cannot remember, sorry.
No worries.
Possibly then the natural language, an NLP Reddit subreddit, possibly one of the machine learning ones. I'm not sure.
Nice. Well, it's great to have you here. And yeah, I'm sure you're already in our Slack community, so we can talk more
yes,
there.
Yep, I'm in the Slack community. I started going through your tutorials, but I didn't spend enough time on it yet. So I'm a little bit intimidated to even ask questions that I should probably figure out myself first, but I am accumulating questions that I expect to ask on Slack soon.
Well, no matter what, we're always happy to hear questions. Jina 2 is so different from Jina 1.0 that we're getting questions all the time. and we're always working on making things easier to use. So if we know what questions are being asked, what pain points, where the confusion is, we are more than happy to hear them.
Yeah, so we're going to have a lot of questions probably around how we can control or influence ranking. So we are a SaaS offering for local governments searching their documents, and they're much more interested in things that happen close to their communities, recent in time, and major events. So if there's a homicide in their town last week, that's a much more relevant document than something 50 miles away, 4 years old, or things like that. So I assume that your multimodal search example is probably the right thing for me to start looking at there, where we would have our own distance and age of document things that get weighed against the similarity of terms within a document. I'm just wildly guessing here. That's the path I'm looking at right now. Hope I'm on the right track.
Any engineer want to chime in on that?
I would recommend also, Ron, to look at the ranking steps. So we have, for instance, in New Jina Hub, our light GBM ranker, where you might be able to train your own models and to do the fine tuning of your ranking at the latest stage, where similarity or BM25 would not get you. There are some.
Yep, because we're going to want to weigh those similarity against, you know, the age of a document or the distance from the user doing the search.
Whatever other feature that you may think, the ranker is the place to look.
Great. Yeah, thank you.
You're welcome.
Great, and who else do we have? I can't say your name. 𝗁𝗁, 𝗁𝗁.
I guess that was not the way.
Yeah, sorry about that. Sorry if I've made you run away. Great. I think I've hassled everyone on here now. Do some of the new team members want to say a very quick hello? Nishil?
Yeah, thanks, Alex. Yeah. Hello, everyone. I've just joined Jina. It's just my first day at Jina, and I'm pretty excited. Thanks for having us, listening to our demo. It's great. Looking forward to you guys in our Slack community and helping you guys with it. Yeah.
Nice. Thanks, Nishil. Winston?
Hi. So yeah, I joined in about a month ago. Actually, no, a couple. Let's see. Sorry, 2 weeks ago. I am currently working on porting some executors and the examples to our Jina hub, and yeah, I'm really excited about the product. And it's really a pleasure working here with the awesome talents in this company.
He didn't even get paid extra to say that.
This is the feedback that I was talking about.
Yeah. I'm not standing over him with a stick or anything either, so don't worry. Great. Any other new faces at Jina? Piper, are you there?
I think Anna from the community wanted to.
Oh, Anna, yes. Please talk away. We can't hear you though.
Me? Oh yeah, she's, yeah.
Oh great, there you are. And there you aren't. Okay, we'll keep your mic open, and if it does work, great. Yeah, in the meantime, Piper, do you want to say hello? Okay, Piper's being shy. right, I think.
Alex, can you unmute Anam Anamari? I think he's asking in the chat.
We don't have her as muted.
Okay.
So yeah, almost everyone else is muted, but Anna, I see your mic is open, but there's nothing, the little black bit in the mic isn't going up and down, so it's getting no input.
Can everyone hear me?
Yes, we hear you.
Oh, hi, I'm sorry. I think I've had it on all this time. Okay, so I'm just a student. I'm soon to start a Master by Research in NLP. I finished a Bachelor in Math, Statistics, and Programming at University of New England in Australia online. So I'm really passionate about calculus, differential equations. I've really found my interest in that. And now I think I want to learn. I also like languages, so I think I want to study the semantic properties of words with NLP and, learn to categorize all this information in this information age. I've also done a scholarship about categorizing the different NLP models, so Transformer XL, BERT, ERNIE. ERNIE is my favorite one, and then XLNet because of the long-range dependencies. In programming, I know some Scala, I know some Java. Scala is my favorite over Python because it's more typed and it's functional. So I'm really passionate about combining the Bayesian statistics and applying it to the NLP. So hopefully to get some distributional background to the embedding. So not just a point estimate, but having also more variance captured in these measurements. So for example, I've read some papers that said there's many words are polysemic, and I think that Bayesian statistics would be really good to capture this variance. So I'm here to learn from everyone, and I'm really glad to be here. So thank you for listening.
Well, it's our pleasure. We were so worried we wouldn't get to. Any of our engineers have any words about that? It's a bit over my head personally.
All that makes great sense. I think also the Bayesian statistics on this not assigning a single embedding for an input, it's quite promising. And I also like Scala over Python, but Python is easier to use.
Hi, Mr. Martinez. It's good to see you again.
Good to see you here.
Great. Is there anyone else who wants to speak up? Okay. Silence is golden, I suppose. So, yep, we'd love to hear from everybody on our Slack. So slack.jina.ai, join the community, and let's talk more there. Until then, I hope to see some of you at the Berlin meetup. I hope plenty of the Korean contingent can make it to the Korean meetup. And everyone else, I hope to see you at the next Engineering All Hands. Same time, same place on Zoom next month. Join our meetup.com group as well, because that's the place to go for all our events. All right, thanks everybody. That's a wrap. Bye.
Bye. Thank you. Bye.
Thanks, bye.
Bye.